Welcome to this lecture. In this lecture, we will discuss about the questions related to preliminary transformation method to find the nth derivative of given function. Let us see the question. Here you can see mixed function is given. Two functions are multiplied. One is algebraic and one is logarithmic. Looking at this function prima facie, we can deduce we have to use the preliminary transformation method to separate both of this function and to bring them to standard form. So we can use the formula to find the nth derivative. Function is given and we have to prove the nth derivative is like this. So we will use preliminary transformation method, and for that we will differentiate y with respect to x. We will get y dash is equal to ln x minus 1 upon x plus 1 plus x multiplied to x plus 1 upon x minus 1 into the chain rule will apply. We will get x plus 1 minus x minus 1 upon x plus 1's whole square. We can separate logs to convert this to standard function. We will get y dash is equal to ln x minus 1 minus ln x plus 1, and this term would become 2x upon x minus 1 into x plus 1. We do have formulas for this kind of functions, but we still don't have formula for this kind of function. So we will have to convert this into partial fractions. This is very simple algebraic function, and we can directly write it as 1 upon x plus 1 plus 1 upon x minus 1, which is equal to 2x upon x minus 1 into x plus 1. So here we can see we do have formula for the nth derivative of this kind of functions. We will get y dash is equal to ln x minus 1 minus ln x plus 1 plus 1 upon x plus 1 plus 1 upon x minus 1. Now we can see all the functions are of standard form, and I have enlisted all the formulas which we can apply. For these two functions we can apply this formula here, and for these two ln functions we can apply this formula. Here you can see the value of a and b is 1 minus 1. Here the value of a and b is 1 and plus 1. The same way here a and b is 1 1, and here a and b is 1 minus 1. Now we have already differentiated y once, so we will differentiate y dash n minus 1 times, so that we will find the nth derivative of y. So we will get nth derivative yn is equal to, first these two terms we will write like this. We will replace n with n minus 1 because we are differentiating n minus 1 times only. So we will get minus 1 raised to n minus 2 into n minus 2 factorial upon, here you can see a is 1, so we don't have to write it, and the function itself, it is x minus 1 raised to n minus 1. The same way for this part, we will get minus 1 raised to n minus 2 multiplied to n minus 2 factorial upon x plus 1 raised to n minus 1 plus. Now we will apply this formula, and here you can see a is 1, b is 1, and we will replace n with n minus 1. We will get minus 1 raised to n minus 1 into n minus 1 factorial. We have a is equal to 1, so we don't have to write it, upon x plus 1 raised to n plus minus 1 raised to n minus 1 into n minus 1 factorial upon x minus 1 raised to n. We can see here, we can take minus 1 raised to n minus 2 common, because that term exists in all the terms. And we can also take n minus 2 factorial common. So in next step, we will get the nth derivative would be equal to minus 1 raised to n minus 2 into n minus 2 factorial into the bracket 1 upon x minus 1 raised to n minus 1 minus 1 upon x plus 1 raised to n minus 1 plus, here you can see minus 1 raised to n minus 2 is taken, so minus 1 is still here, so we will write minus 1 into n minus 1. As n minus 2 factorial is taken, so n minus 1 is also remaining here, upon x plus 1 raised to n plus, the same way we have minus 1 into n minus 1 upon x minus 1 raised to n. Here you can see the denominator of these two terms are similar and denominator of these two terms are similar. To make the denominators equal, we will multiply and divide this term with x minus 1, and we will multiply and divide this term with x plus 1, so that the denominator of these two terms would become equal and the denominator of these two terms would become equal, so that we can do the addition of numerators. So we will write the nth derivative equal to minus 1 raised to n minus 2 into n minus 2 factorial into the bracket, we will get x minus 1. Now we are taking these two terms into the consideration. We will get x minus 1 minus n plus 1 upon x minus 1 raised to n. Now let us take these two terms into the consideration. We will get plus 1 minus n minus x minus 1 upon x plus 1 raised to n. Simplifying this, we will get yn is equal to minus 1 raised to n minus 2 multiplied by n minus 2 factorial into the bracket x minus n upon x minus 1 raised to n minus x plus n upon x plus 1 raised to n. Here f of x is equal to this function is given. Just by saying this function, you can say to separate those functions, we can use this kind of formula, either this or this. As we can make out a formula of cos plus cos from this function. What we will have to do is f of x is equal to, we will write cos x into half multiplied to 2 into cos 2x into cos 3x. You can say this is similar to this. So now two functions will get separated, and it would be cos x into half of cos 5x plus cos x. Now we will multiply cos x inside. We will get f of x is equal to half of cos x into cos 5x plus half of cos square x. Now for this we can use this formula to convert this function to the standard form, and for this we will again use this function. So the next step would be f of x is equal to 1/4 of 2 into cos x into cos 5x plus 1/4 of 1 plus cos 2x. We can take 1/4 common from both of these functions, and we will get f of x is equal to 1/4 of, this would become cos plus cos 4x plus cos 6x plus 1 plus cos 2x. You can see here 1 is constant, so nth derivative would be 0. Now we will apply the nth derivative formula for these functions, which is cos ax plus b. This is the formula for the nth derivative of cos ax plus b. This is the formula we will apply. So we will write differentiating f of x n times, we will get the nth derivative of x is equal to 1/4 is multiplied, so it would remain outside of the bracket, and we will write the nth derivative of these functions. For cos 2x the value of a is 2, for cos 4x the value of a is 4, for cos 6x the value of a is 6, and we can see here there is no b is 0. We can directly write the nth derivative of all of these functions. 2 raised to n into cos 2x plus n pi by 2 plus 4 raised to n into cos 4x plus n pi by 2 plus 6 raised to n into cos 6x plus n pi by 2. See, in this question, this function is given and we are supposed to find the nth derivative. Here let us separate those functions. To separate them, we would write f of x is equal to e raised to 2x into cos x into half of 2 into sin x into cos x. We have formula of sin 2 theta. Now we would get f of x is equal to half of e raised to 2x into cos x into sin 2x. We can see here, as cos and sin are multiplied, we can use this formula. Again multiply and divide this by 2. We would get f of x is equal to 1/4 of e raised to 2x into 2 into cos x into sin 2x. This is formula of sin plus sin. We would get f of x is equal to 1/4 of e raised to 2x into sin 3x plus sin x. Now we will multiply e raised to x inside the bracket. Still we are getting the standard form. So the final answer we can deduce from this form. We will get f of x is equal to 1/4 into e raised to 2x into sin 3x plus 1/4 of e raised to 2x into sin x. Now these both are the standard forms. This is the form, this is the standard form we are getting here. You can see here for this function value of a is 2, value of b is 3 and c is 0. For this function value of a is 2, value of b is 1 and value of c is 0. We can now directly write the nth derivative. We will write now differentiating f of x n times we will get the nth derivative of f of x would be 1/4 of 2 square plus 3 square raised to n by 2 into e raised to 2x into sine 3x. As there is no value of c, we would now write n into tan inverse 3 upon 2. And for the second term, we would write plus 1/4 of 2 square plus 1 square raised to n by 2 into e raised to 2x into sine. Value of b is 1, so we would write x. There is no c, so we don't have to write it. And the next term would be n into tan inverse 1 upon 2. So again, we can take 1/4 and e raised to 2x common. So the final answer would be the nth derivative of function f would be 1/4 into e raised to 2x into the bracket 13 raised to n by 2 into sine 3x plus n into tan inverse 3 by 2 plus 5 raised to n by 2 into sine of x plus n into tan inverse half. And this would be our final answer.